Okay, so you're on page 434. Tangents is the next section. Here's what I want you to think about, because some of you guys are still like, well, what is a tangent? Okay, and I'm not talking about sine, cosine tangent, not that kind of tangent. What I am talking about, however, yes. Alicia is saying. Okay. Oh, you actually have the notes. Here's what I want you to think about. When you're talking about a story, talking, you're talking with your friends, you're having a conversation, la la la, everything's great, and then you go, oh, wait a minute, sidebar, I just want to tell you something. By the way, I'm not going to be home. You know, I can't call you after dinner tonight because I'm going to a soccer game. Okay, continue the story where you left off. You guys know how you do that all the time?
No, I don't know.
A sidebar. A sidebar. Any, by the way. Oh, by the way. Okay, except for that one. Any sidebar, any by the way, that's a tangent. Okay? Think of it this way. Think of it, here's your story, here's the conversation that you guys are talking about, and then, something obviously had reminded you of why you wanted to branch off just for a second, but it is a completely different thing. Tangent. Okay? Otherwise known as sidebar. Okay? That's literally what it is. Look, it's on the side, and it's like a bar. Sidebar. Tangent. Not a candy bar. Sidebar. Okay, what we're doing today, adding to the things that we already know about our circles, you are going to be using inscribed angles. You're going to be using everything you know about arcs and central angles and radius and diameters. Okay? You're just adding to it now. Okay? If you do not have this so far drawn, please draw it now. Okay? The one quick thing, the one vocabulary term of this section, okay, is the point of tangency. Okay? Not the point of no return, point of tangency.
Is it the dot where it becomes a tangent?
Hey!
Yo, I'm a magician.
Not quite. The point of tangency. Thank you. The point of tangency is that dot. It's the point where the line and the circle meet. The one point where a line meets the circle. Okay? Yeah. No, the point of tangency. Okay, think of it this way. It's the point at which you go off onto your sidebar. Okay? The point where the line meets the circle. Okay? The point where the line meets the circle. So in our case, it'd be letter A. Okay, this is our point of tangency. There is not a symbol for that. Sorry. I mean, usually we could just call it point A. But there is no symbol for point of tangency. Sorry. Okay. The three things that I want to go over are the three banners that are in this section. Okay. The first banner, the first thing that we are going to be reviewing, okay, is Theorem 9-8. Theorem 9-8. Okay. If a line is tangent to a circle, if a line is tangent to a circle, if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. If a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. Now what you need to think about here, guys, okay, is that everything that you learn, all these theorems and all this kind of stuff, it all has to do with the stuff that you already know, stuff that you've learned in the past. So what would it matter if we know that we have any point of tangency here, and if the middle of our circle is, I don't know, say here.
Your attention, please. At this time, I wanted to inform everyone that the 7th grade has returned from their library field trip and are heading to class at this time. So kindly accept those 7th graders into your 8th hour class.
So exciting.
Without a pass. Thank you.
Okay. Why does it matter if we do not know, why does it matter if we have a perpendicular line from the center of the circle to the point of tangency? Well, we know many things about our circle. We know many ways to figure out angles and such. So let's see. If I were to make this radius here, okay, now I have radius PA, and I know that this is a right angle. Okay, let's say that my radius here is, I don't know, 4 units. Okay, and if I knew that from the center of my circle to another point on that line, on the tangent, I'm saying, do you see that? I'm not on the circle anymore, I'm on the tangent. I'm outside of the circle. Okay, if I go to another point on that tangent, say this is point, I don't know, T. Now all of a sudden, what have I created? I have created a triangle, not only a triangle, but a right triangle. Okay, now I can do everything I know with right triangles. I know what my radius is. I know, now I can also tell, just in case I need it, I can also tell what my diameter would be.
It's an 8.
That would be an 8. Very good, Skylar. Okay. And say I know, just because, again, it's my favorite right triangle, if I know the distance between A and T is 3, now all of a sudden I can say the distance between P and T, or I could use the Pythagorean theorem in which to find it.
5.
Spoiler alert, yes, this one would be 5.
BT dubs.
Okay? Got it. Okay. All right. So that is what theorem 9-8 is, just saying that if a line is tangent, okay, if a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. Okay, it has to be at the point of tangency though. Even if you have a point here, point of tangency, and you are just a little bit off and it is not the point, let's say here that point does not intersect with my circle, that will not be a right angle. Okay? The whole thing with geometry, now that we are getting into those later chapters, it's all about everything that we've learned in the past. You cannot let go of all that stuff you learned in the past. Just like when we do some of the examples and problems in here, when I say, okay, I'm going to give you a few problems that are just, you know, it gives you numbers and you have to just kind of figure out your own problems. And then I give you some that have to do with algebra, where I say a radius is 2x plus 1, and then you groan and say, oh, it's because I care. That's it. Why do I care so much?
Why not?
Drat! Curse me, I care too much about you guys that I ask you to exercise your algebraic brains.
Ew.
Okay, next one. Theorem 9-9. Our next point that we are learning, ready? Next point we're learning, in a plane, now here's the best part. When you have one thing, Theorem 9-8, when you learn one thing new, if you can think in your head how the opposite of that would be, you technically learn two things. Theorem 9-8 says if you have a tangent to a circle, then you have a perpendicular line to the radius at the point of tangency. Theorem 9-9 is just the it's flipped. It's the opposite. It's the converse, if you will. Okay? I know. Well, dang it. In a plane. I know. In a plane, which means, once again, we're not working with three-dimensional figures right now. If a line is perpendicular to a radius of a circle, yep, at the end points on the circle. So in a plane, if a line is perpendicular to a radius of a circle at the end point on the circle, then the line is a tangent. Can a circle be tangent to a circle? Yes, it can. How could it be tangent to a circle? If they only meet at one point. So think of not a Venn diagram, but something rather close to it. Bing.
I think church hates me. They only make it relate.
Owl eyes.
They only make it relate to me. It's not the good stuff.
Not the good stuff?
No.
Very sorry.
They teach me about failures.
And you being a failure?
Yeah. Yeah. We learned
Okay.
about it again.
Okay, I would like us to take a second right now to appreciate the scope of what is happening. Are you ready?
I'm 100% ready.
In a plane, if a line is perpendicular to a radius of a circle at the end point on the circle, then the line is a tangent. Vinny asks, can a circle be tangent to a circle? Absolutely. Here we go. There you have it. Then Justin says, I think church is out to get me. Well, sidebar.
You're welcome. I proved your point.
Thank you for our tangent of the day, Justin Jerombo. Did you hear him say that?
Why is church up to
Justin's talking about church telling him that he's failing and stuff
I
like that. Did you hear? He started this whole conversation about church all of a sudden.
The church hates me.
Church hates him. That's what he said. Church hates him. That's what he said.
Sidebar.
Can a circle be tangent to a circle? Yes, it can. I think church hates me. That's how it went.
There's eyeballs.
Well, wait, then that circle would be the church thing, and then we'll go back to our actual conversation.
Yep. Sidebar. And we're back.
Is one of those circles a tangent? Like an action? It's confusing because, like...
Is this okay? So Vinny says, can a circle be tangent to another circle? Yes, it can. They only meet at one point. Bing.
But, like...
Both of those, the point of tangency is right here where they intersect.
But, like, is one of the circles a continuous tangent thing?
Yeah.
Which one's the actual
Yeah.
tangent itself?
Well, here's circle A. Here's circle B. Circle A is a tangent of circle B, and circle B is a tangent of circle A.
So it's a continuous loop. It's really crazy.
Continuous, infinite tangency.
But it's only once. Infinite once.
Infinite once. Infinite once.
Great job,
Nice,
Vinny.
Vinny.
What would happen
Oh.
what would happen if Pinocchio said, my nose will now grow?
It's a paradox.
It won't. Oh my god, that's so
It's a paradox.
Oh my gosh.
But then that would be a lie.
but that would be a lie. Oh my
So
god.
then it would grow,
Why
but
do you
then
say that you're
you'd
always
be telling
wrong?
the
What
truth.
if you
So
tell
then
them I'm about to not listen to you?
Oh my goodness.
Okay, let's bring it back.
I am amazed.
Paradox.
We have amazed Alicia. We have one last theorem we need to go over, one last point
Yo, I
before
love,
we start going over actual practice problems.
I love getting writer's block.
Got it? Oh, actually, I lied. We have two more things to go over. And Alicia has like 2 minutes, so we gotta move.
Say Nick.
Okay, ready? 9-10, theorem 9-10. If two segments from the same exterior point are tangent to a circle, then they are congruent. If two segments from an exterior point are tangent, I wish there was a symbol for tangent, are tangent to a circle,
Tan is the symbol thing.
tangent to a circle,
Tan, love this.
okay, then they are congruent. What does that mean?
It means that
Ready? I'm not going to have an awesome circle.
I think it's the best.
Okay.
circle ever.
Here's my potato. Okay. So there's my circle. Now, what it says, if two segments from an external point, bing, there's my external point. Okay. So I have circle A, exterior point X. And I have one tangent here. Bing.
Oh, that's
See that? Because they meet here.
here.
And one tangent here.
What did that make?
Pretty sure I created the clown Illuminati.
Boop.
Not the clown.
If my circle were actually a right circle and a correct circle and not a potato.
I just created the clown
Okay.
Illuminati.
What that would mean, these two segments here would be congruent.
Excuse me, but those are very congruent.
They only don't look congruent because I drew a potato.
No,
That's fine.
mine. Hey,
What?
Potatoes are always congruent. Trust me. I'm a farmer.
If two segments from an external point are tangent to the same circle. Lame. Okay? It means that these two segments are now congruent. Okay? In other news, check it out. If you went from the center of your circle to the point of tangency to each one of those, this one's perpendicular, and this one's perpendicular. I can also connect these two.
Oh god, what is that?
What does that mean those triangles are?
It's a duck.
Besides being a duck, what are these triangles? Congruent. They are congruent triangles, and I have formed them not by just using this theorem, but by saying, oh, I can make this radius, and I can connect those two. We'll miss you forever, Alicia.
Alicia.
Is there
Oh, one more thing, and then we'll take a break, okay?
We'll miss you forever.
Do you understand Theorem 9-10?
Yes.
Moving on. I've got my two circles here,
AKA eyeballs.
aka my eyeballs. That's why I called them owl eyes earlier.
Mine are butterflies.
Okay.
Those are both lemons.
We are going to go over two separate things right now. Ready? One of them is going to be a circumscribed,
What?
Oh god, I'm scared.
Yep,
I don't like
polygon.
I don't like learning new
I will
things.
never spell that correct.
circumscribed
Polygons?
polygon.
Polygrams.
Sure.
Yo, it worked. I said polygrams and it worked. See, Skylar, I told you it would work.
What would work?
Polygrams.
What's a polygon?
My new cereal. I'm launching it next week.
Is it just different shades?
It's a new polygram.
Or is it just circles? All of the above?
It's a gram of polygram.
Oops.
Sidebar. I'm scared. I don't like learning new things.
Tangent.
Well, you're not going to go far.
There you go.
I am. It's just I'm
This polygon, my awesome pentagon, 1, 2, 3, 4, 5. A circumscribed polygon. A circumscribed polygon.
Mine looks really messed up.
Polygon
Look at my
immediately.
I think this is animal abuse.
What is your name?
Polygon.
Justin. I almost called him Liam because I was thinking Skylar, and then Skylar and Liam, and that's not right. Never mind. Justin, are you done?
Maybe. I don't know. Yeah, sure.
A circumscribed polygon, what is it? Is a polygon immediately on the outside of a circle? Each side must be touching the circle at one point. Ding, 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 ding. See that? Circumscribed polygon. Okay, now, okay, the polygon, are you ready? Okay, think about this. The polygon is circumscribed. The polygon is circumscribed. Okay, the polygon is circumscribed. However, the circle, okay, listening because I don't want you to get confused. The polygon is circumscribed. It's on the outside, right? The circle is inscribed. Just like how we talked about inscribed angles.
That's so cool.
Polygon's on the outside, circumscribed. The circle's on the inside, inscribed. Inside, inscribed. Inside, inscribed.
Yeah.
Thank you, sir.
All my friends got me
Yeah, it was a dump theorem.
Inscribed polygon. Inscribed circles.
I can even do this and go. Whee! And
Hexagon now.
whee! And whee! Whee! And connect those. Boop. Boop.
Can't tell what shape that is.
Quadrilateral.
Oh, I can make that. What is it, Alex?
The quadrilateral is circumscribed. The circle is inscribed.
Interesting.
That's so awesome.
Very, very
I tell all my friends about this.
No way.
I'm a duck.
Okay. Once you have all these notes, then you may take a break.
I'm a duck.
Oh, yeah, by the
Hey,
way,
welcome
back with
With cooking with
That's what I'm talking about.